As our first introduction to Haskell, let's use it as a calculator. Start up GHCI, which is the Glasgow Haskell compiler in interactive mode. After some initial messages that we can ignore, GHCI gives us a prompt, the word prelude followed by a greater than sign. If we type in a simple arithmetic expression here, Haskell evaluates it and shows us the answer. The usual operator precedence rules apply. If we type 2 plus 3 times 5, the multiplication happens first and we get 17. There is an idiosyncrasy having to do with negation. Regular subtraction is fine. 8 minus 3 is 5. But if we try 2 times minus 4, we get an error. We can fix this with parentheses. Numbers behave slightly differently in Haskell than in some other languages. For one thing, division behaves the way most people would expect. 3 divided by 2 is 1.5. Programmers used to other languages might have expected 1, because integer division in C and Java discards any fractional part. Haskell's slash operator returns a floating point number. Haskell also allows us to store extremely large numbers. For example, consider the classical Asian game of Go. In this game, players take turns placing black and white stones onto the intersections of a 19 by 19 grid of lines. How many different board configurations are there? The first intersection can be vacant, contain a black stone, or contain a white stone, so there are 3 possibilities there. If we consider 2 intersections, we have 3 possibilities for each, giving a total of 9. For the whole board, then, we have to raise 3 to the power of the number of intersections on the board. Let's ask Haskell. The caret or up arrow operator performs exponentiation. We need the parentheses here to make sure the multiplication happens first. That's a big number. In fact, it's many orders of magnitude larger than the number of electrons in the universe. If we tried to store that in an int, or even a long in Java, the value would overflow. As in Java, but unlike in C, Haskell also has a special Boolean type. The 2 values are true and false, both with the first letter capitalized. These can be combined with the operators and, or, and not. Equality is tested with a double equal sign. The opposite is slash equals. Most of the functions we've seen so far have been infix, with the function between the arguments, as in 3 times 5. Can you spot the 2 exceptions we've seen? One of them is not. The other is the unary version of minus. Since these functions only take 1 argument, they must be prefix, with the function before the argument. Except for arithmetic operators, most Haskell functions are prefix. Here's another example. Notice that there are no parentheses. Haskell tends to use fewer punctuation marks than other languages. Function application has higher precedence than arithmetic operators, so max 3, 5 times 2 is the same as max 3, 5 times 2. It's a matter of taste whether or not those parentheses should be included. If you're ever unsure about the order in which things are being evaluated, try including parentheses. One last point on function application. A prefix function can be made infix by enclosing it in backticks. The backtick is the reversed apostrophe at the upper left of your keyboard on the same key as the tilde. The following are equivalent: max 3, 5 and 3 backtick max backtick 5. Again, which version is clearer is a matter of taste and may depend on the situation. When you're ready to leave GHCI, either type the command :quit or send an end of file character with Control D. In the next video, we'll start defining our own functions.